In this video, we're going to explore reactions of amines with nitrous acid. Recall that nitrous acid right here is the conjugate acid of the nitrite ion. Nitrous acid itself is fairly unstable, so it's generally made and then used immediately. We will be making it here by reacting it with HCl in a very simple acid-base step right here. In the presence of excess HCl, we can protonate the OH to make it a better leaving group, and then we can make it leave with the lone pair on the nitrosyl oxygen. Second set of arrows here, lone pair resonates in, kicks off water, a good leaving group, creating the nitrosyl cation, shown here. Nitrosyl cation is very versatile. It can be used as a diagnostic tool to determine what type of amines you have in a solution. It can be used synthetically to create diazonium dyes, N-nitroso compounds, or set up a cool reaction which we'll see in part 2 called the Tiffano-Damianoff rearrangement. Let's take a look one at a time what the nitrosyl cation does to specific amines. Nitrosyl cations are very reactive electrophiles, and amines are pretty good nucleophiles. The amine pushes its electrons towards the nitrogen, and the pi breaks and becomes a lone pair on the O, thus neutralizing the O, generating this result. We have an N-nitroso ammonium ion. Yes, this is called a nitroso group. And here's an ammonium ion, which is going to undergo tautomerization, where the base grabs an H. The sigma becomes a pi, and the old pi picks up a proton. We've seen many tautomerizations in these two courses. And the result is depicted here. We have this protonated species here, which will undergo what looks like a tautomerization again. But in this tautomerization, we have water leaving, which means, in effect, it is really an elimination. We're going to get a triple bond between the two nitrogens here. And this is going to protonate to make it a better leaving group, and it will leave. What we have generated here is called a primary alkyl diazonium ion. Diazo means two nitrogens. The fate of a primary alkyl diazonium ion is one of recklessness. It is a primary carbon attached to not a decent leaving group, not a very good leaving group, not an excellent leaving group, but an exceptional leaving group. This thing will react with basically anything that has a lone pair, and there are several of those species around, and it will generate what we call a dog's breakfast. Any reaction that creates a multiple of organic products is messy at best, and there's many better ways to create this alcohol, this alkyl chloride, or this alkene. So we don't find a great deal of utility with nitrosyl cations reacting with primary amines, except as a diagnostic test. The presence of bubbles at the end indicates that you started with a primary amine. As you will see with the mechanisms of secondary amines and tertiary amines, where we do not see the gas generated. We first heard about diazonium ions in chapter 22. In that context, we were talking about aryl diazonium ions, and if it's an NH2 attached to an aromatic ring, it's a primary aryl diazonium ion. These are different than our new primary alkyl diazonium ion in that They're unstable, but not as exceptionally unstable as this thing. If you keep this thing below 5 degrees Celsius right here, it will stay as is. And then you can slowly warm it up in the presence of other chemicals and create useful aromatic compounds. In fact, this is our only way we've learned to date about how to make an aryl phenol. You take your aryl diazonium ion, warm it up to room temperature, and the water in this mixture is what provides the oxygen for the OH. Aryl fluorides can be made using fluoroboric acid. Warm it up to room temperature, and you get your aryl fluoride. We have two more ways of making chlorides and bromides here. We have our first way of making an aryl cyanide here, and an iodide, and an unsubstituted aromatic here. You might want to go back to chapter 22 and see when this reaction might ever be useful. So once again, in summary, aryl diazonium ions from primary aryl amines are useful. Here's a summary. Unlike primary alkylamines, a primary aryl amine finds great synthetic use because its reactivity can be controlled a lot more easily. Moving on to secondary amines. Mechanism starts identical to the mechanism on top, generating this ammonium ion with a nitroso on it. This ion is not capable of tautomerizing to a useful intermediate. It simply undergoes an acid-base reaction, generating an N-nitrosamine, in this case N-nitrosodiethylamine, which is a known carcinogen. A lot of these carcinogens are generated from tobacco smoke. And that's the end of that reaction. So we do not generate diazonium ions. We generate this new functional group we know to be a nitroso functional group. And you can tell this reaction has happened because typically the product is a yellow oil. So instead of generating nitrogen gas, which was a visual sign of a primary amine, you've generated a yellow oil, a visual sign of a secondary amine. And I just noticed a typo here. That was a secondary amine, two ethyl groups on the nitrogen. Tertiary amines next. A tertiary amine, without a hydrogen to lose on the nitrogen, is not really interested in attacking nitrosyl cation. There's no way to neutralize the ammonium ion that you formed. So instead, you get a simple acid-base reaction with the HCl present from the beginning. Yes, that HCl was used to make nitrous acid. Don't forget that. Get a simple acid-base reaction with the result being as follows. We have triethylammonium ion. The interesting thing about that is it is now water soluble. Triethylamine, the amine you started with, was not water soluble. So as this reaction proceeds, you would notice an oil sitting on top of the water, which was the amine, colorless oil. And as the reaction proceeds, you would see it dissolve. So there would be no more oil sitting on top. A summary of everything we've seen on this page is here. Let's just reveal. And there you have it. If you have a primary amine, you're going to see bubbles. If you have a secondary amine, you will see the formation of a yellow oil called a nitrosamine. If you have a tertiary amine, you will see the amine that was not dissolving now dissolve. And that's it for this discussion, introductory discussion of the reactions of amines with nitrous acid. The concluding video will be coming shortly.